Gábor Szappanos. He started antivirus work in 1995. From 2002, he's been the head of virus lab at Virus Buster. And he's a frequent speaker at antivirus conferences, has authored several articles on the malware analysis. Currently is the malware researcher at Sophos, and I'll let him take it away. Take it away.
Thank you very much for the kind introduction. This kind of introduction makes me feel certainly old. And I get the urge to have this presentation sitting in an armchair, sipping whiskey and talking about good stories about the old 90s where dinosaurs ruled the earth and we could list all the known viruses by names and we knew all of them. But unfortunately, that's not the kind of presentation I prepared for you. I intend to talk about a threat which is a lot more relevant and new. In fact, I'm talking about the Blackhole exploit kit, which can be considered the #1 web threat of the past 2 years. So the first part of the presentation will be about the exploit kit, the history of this exploit kit, some difficulties into the analysis of the exploit. The second part, I will talk about how the attacks using the Blackhole exploit kits are really working in practice. I will start my presentation with a disclaimer. The whole presentation is not my fault entirely. I had two partners in crime. One of them was being this guy who started the work, the initial analysis while he was working back at Virus Buster. He collected the first samples and made the first assumptions about the workings of the entire exploit kit. And I must tell you, he made a lot of mistakes there. Over the course of the last couple of months, I tried to fix most of his mistakes, and if any error is spotted in the presentation, it's his fault. I have nothing to do with it. And I had another external resource used in the creation of this presentation. It's Joumey, former colleague of mine at Virus Buster. He was the head of the engine development team there, and he now works at Yahoo. But none of this is relevant for this matter. He's an experienced PHP programmer, and when my very limited resources of PHP knowledge exhausted pretty soon, I asked for his help to have a better understanding of the operation of the server backend. He helped me out in a couple of questions where I got stuck, and without him I couldn't have understood in the whole complexity the operation of the complex. So let's take a deep dive into the Blackhole exploit kit. As I mentioned, this can be considered the #1 web threat as of late. This chart represents the statistics gathered by Sophos Labs about the different web threats that we have experienced over a half-year period of time. And over 2/3 of these web threats can be attributed to one sort of exploit kit, server-side exploit kit, and half of them is the working of the Blackhole kit itself by alone. So 1/3 of the threats that we are facing and coming through the web are the result of the operation of the Blackhole kit. The Blackhole kit is an exploit kit, which means that it is a server-side collection of programs. It has a SQL backend and a PHP admin interface and a PHP working functions. It has a very flexible pricing scheme, rental business model. It has a built-in traffic direction system, which means that it can serve different content, exploiting different vulnerabilities based on the identified operating system and software environments on the target machine. It also has a feature of blacklisting IPs which can be useful if they identify the IP range of a malware analysis lab. They can blacklist it, and in that case, that lab will be excluded from receiving or downloading new samples, and which makes a lot more complicated the analysis. It has an integrated antivirus check service. The exploit kit is utilized to distribute some kind of Windows binary malware, usually Trojans, to the victim computers. And it is very beneficial if this distributed malware is not detected by the antivirus software at the time it is distributed. So the server side has a functionality and pre-installed antivirus software, and the operator of the site can check if the malware it is intended to distribute is still undetected to this software, the antivirus software. It also has a management console which gives out detailed statistics about the exploit being delivered and the computers being infected. Sorry, wrong button. The kit has been around for about 2 years. The first beta version appeared in 2010, in August, sometime in the August of 2010. And just about a month ago, a new major version, 2.0, was released. And in this period of time, every few months, a new release of the exploit kit appeared on the black market. Mainly, the changes were related to adding or removing an exploit function, exploiting a new vulnerability in the exploit kit. The analysis of the server code will be based on the source code for the 1.0.2 version, which is kind of oldish, about two years old, but is one overwhelming advantage over the later versions. It is available for analysis. The later versions are not known to be in circulation in the security research community. These are known and available only for the author of the exploit kit and its customers. As I'm clearly not any of them, I had to work with what I had in hand, which is a 1.0.2. I was a little afraid that it will be outdated, and whatever conclusion I come using this dinosaur will not be relevant for today's threat. But it turned out that the overall operation and the general structure of the exploit kit has not changed too much. In fact, it has not changed significantly ever since in the major version line 1.x. So as I mentioned, it has a flexible pricing scheme. Annual license is available for $1,500, and it can go down to short-term rents. Also, it has two kind of purchase strategies. Either it can be purchased for hosting on the customer server, or hosting can be rented on the author's server, which is even more cheap. And I must note one thing. This pricing scheme was from the release notes of version 1.0. And about 2 years later, when the version 2.0 came out, it used exactly the same pricing scheme. So no matter how much the oil prices went up, or the Eurozone crisis did not affect it, not even the global inflation, it kept its value. So it is so reassuring to see that there are some values in our lives that are stable. As I mentioned, it has a traffic direction system. I will tell you very briefly what the traffic direction system is. Its main aim is to deliver code that can exploit exactly the software environment that is available on the target computer. So if a couple of years ago, you could hear general advice that you should not use Internet Explorer, use any other alternative browser, because Internet Explorer is the #1 target for when it comes to exploiting a browser vulnerability. So if the malware authors and attackers are aiming the most prevalent browser, and this will be Internet Explorer, if you're not using it, that you are not prone to these attacks. Now the traffic direction changes this scheme completely. In normal web traffic, you send a query to the server and you receive a response to the content of the web page. In a TDS scheme, the server is injected a code which redirects some of the traffic to the exploit kit hosting computer. If you send a query to the server, it returns the original content, but plus also it returns to malicious content which is tailored to your host system. If you query from a different computer system, you will receive the original content and the malicious content which is different from the first one because it is custom tailored for your computer. These TDS systems build on the request headers that they are receiving during web browsing. And the most important fields that can be used, the user agent from which they can extract the browser version and the operating system version. They might use the referrer where the browsing came from or the language settings. In case of the Blackhole exploit kit, it is using the browser version and the operating system version, also the IP address that it can get from the PHP server application. So depending on these values that it receives for these versions, it can determine that the particular browser, it will come back. The particular version of the browser is vulnerable to any kind of exploit. So if it is receiving back, it should be going. We will solve this problem, technical problem. So if it detects that it is running Safari, it will check if it has an exploit that is targeting Safari in the server backend, and it will prepare it in the response. If it detects it is running Mozilla, then it will return a particular exploit representing that. Okay.
Ja, akkor dupla képernyőre van tévé, csak megint osztva, azt is kiszállítom.
Okay. Problem solved, whatever the solution was. Keep restarting until it works. Anyhow, the event that triggered this presentation happened in 2011 May, when on the underground forums appeared the information that the source code of the Blackhole exploit kit leaked out. At that point, it was expected that this leaked out source code could lead to an offspring of modified versions of this exploit kit appearing at a very fast rate in large numbers. It has happened before when the source codes of worms like EgoBot or SDBot appeared on the back market, or recently when the source code of the Zeus Trojan appeared also for public availability. Suddenly, a lot of wannabe virus writers started to tweak the source code, made minor modifications in them, and tons of new versions arisen from that original incident. But in case of Blackhole, it didn't happen. It was very surprising to see because it was a successful and very widely deployed and used exploit kit. So given its great success, it would have been expected that whoever took a look at the source code and could, with minimal work, develop a new version would push it out to the market. And it didn't happen, and we will see why it was exactly. But the first question is, how the exploit kit was stolen in the first place? How did it get out of the servers? It is a PHP-based exploit kit. Getting PHP files out of a running server is a very difficult problem. Unless there is an include vulnerability in the PHP backend code, it is not really possible. It is not the case with Blackhole. So the only solution is to break into the server somehow. These servers were maintained by the author and kept under very close control. So it was interesting investigation how this source code was stolen in the first place. Now, in the picture you can see the general structure of the source tree. There are a couple of administration-related files. There are these files that are related to distributing the exploit. This is also related to distributing the binary payload of the attack and the statistics page. And there is this peculiar file in the files directory with a really meaningless name, 27, which was interesting to see there. Why was it interesting to see there? In the files directory, normally the binary payloads are stored. These are the files that are distributed during an infection campaign. These are the Trojans that are the end effect of infecting the user computer. Now, in this case, it was not the Windows executable as one would normally expect. It was the C99 shell backdoor program. It is a well-known backdoor used in hacking into website and stealing the content from the website. It could still be possible that it was used by the Blackhole kit to distribute somewhere to some endpoint for whatever reason. However, by design, after reaching the point that I could analyze the server code, by design it can only deliver executable payloads, Windows executable payloads. Everything that is distributed from the Blackhole kit is delivered as application MS download context. So it cannot be a script. Moreover, this file is not referenced anywhere in the server code. Its coding style is totally different from the server code. And unlike all the source files that are used in the server complex and has meaningful content, it is not protected with the ionCube PHP protection. So, as a result, this is an alien body within the Blackhole server complex. So it is my most likely conclusion is that it was not placed there by the author. It was placed there by the attacker to hack into this website. So he had to upload this file to the server. To upload this file to the server was only possible after admin authentication, because that's how the upload works. So first, he had to gain admin rights to go through the login interface. Now that's another question. How could he gain admin access? No? Not Blackhole.
Szerintem azt
No problem, we retry it again. So in order to gain, get to the file upload, it had to gain admin access. It is not possible to bypass, as far as I know, this login, so he had to guess the admin password. Now, how was that possible? I start at the end. The config file for the server complex contains the MD5 value of the password. It is a very relatively safe practice to not store the password in the config file, only the one-way hash of it. Maybe it's not MD5 the best choice for that, but that doesn't really matter. From that, I could get the MD5 of what the original password was. So I made an attempt to crack that password. I was using Hashcat, which is one of the popular password cracking programs, and I was downloading just randomly a generally used dictionary for a dictionary attack. So the end result was that the original password used for protecting the server code could be cracked in 300 milliseconds, which means that it has to be a very, very weak password, which is at the beginning of approximately every dictionary attack password lists. It is a general advice. If you are running a server backend, which has an admin interface exposed to the web for general availability, you should select your password very carefully so that it wouldn't be cracked easily. Especially this is true in the case when you are running some sort of criminal service. You should protect it even more carefully. So, in this situation, using a password like 123 will make you look very unprofessional. And this is what happened in this case. So, here is my guess how the source code stealing happened. During one of the campaigns, based on the distributed malware, the attacker identified the server hosting the exploit kit. Surely I'm disturbed for some reason. After that, it reached to the login, admin login page. The location of the page could be easily guessed from the screenshots that were used when advertising the new versions of the exploit kit on the internet forums. And once at the login page, I would estimate in about 5 to 20 attempts, he could guess the correct password and break into the site. After that, reached to the file upload service and uploaded the C99 shell program, opened it directly in a browser, and from that on, he already had a graphical shell account to the server and it could download any file from it. I believe the next page will be about the origin of the malware, if I remember correctly. Now, it's always a good question how, where a particular piece of malware is originating from. So, after having been here at Hacktivity for these 2 days, I realized that a presentation without a live demo would look very pitiful and unprofessional, and I cannot afford that. So I prepared a live demonstration for you of one of the sophisticated tools we can use for determining the origin of a particular piece of malware. So, if it heads, it's coming from Russia. If it tails, it's China. Okay, it's Russia. And I must tell you, we consider ourselves very lucky because I couldn't catch the coin, or if it lands on the edge, then it is state-sponsored malware. In which case, we would be waited outside by government agents with black suits and these fashy pants, and that's really not something we would like. So I'm really happy that the outcome was Russia. And to somehow feel that not everyone in the audience is convinced about the scientific value of this tool, for them I prepared some additional facts just to support. Somewhere here. We never give up. So there are some additional minor facts which could underline the origin of the source code, where it was developed. The default time zone in this installation is hard-coded to the Moscow time zone. So the user interface supports two languages, which is English and Russian, and it can be switched between these two languages. I'm not a native English-speaking person, but even I could recognize that the English text used in the user interface were in some places incorrect. And I'm also old enough to be of the generation that had to learn Russian for at least 10 years. So from the remnants of this knowledge, I can more or less judge that the Russian texts in the user interface are much more correct than the German case. So there are two basic options. Either the author is English and the customers are Russian, or the author is Russian and the customers are English. And because certainly English is not the native language of the author, we are left with the other one, with our option. And there are two character encodings supported in the code. One of them is general UTF-8, the other one is Windows 1251, which is a Cyrillic character set. And finally, the date format in the code in all places is set to Little Endian, which is day, month, year. This is used in the vast majority of this planet, except for the two other usual suspects, because United States using Middle Endian, which is month, day, yes, month, day, year, yes, and China uses year, month, day, and that includes those usual suspects. Also, there is this minor fact that the new versions of the exploit kit are always announced first on the Russian website by the person who claims himself to be the author, and he's announcing them in Russian on Russian forums. These are all pointing in the same direction. Now, I'm making it look funny, first because we are at the end of the Tough and Dense conference, and I try to cheer up the audience. The other question is, the other reason for doing it is that we should keep reminding ourselves that we are analysts with hardly any knowledge in investigation and covert operations. We make our conclusions on the code that we are looking at. In the code we are looking at, there are signs that are left there by the author. either unintentionally, because they didn't realize that some comments, some variable names, or some constants can be revealing, or they were left there intentionally, because very much know that these signs can be revealing, and they can mislead the investigation regarding the origin of the source code. So we should always take into account that whatever we see is maybe there for us to understand, or maybe there for us to disinform. So every conclusion about the origin of a particular piece of malware has to be supported from different sides, and even then taking with precaution. So let's get to the server code itself. And here is one of the source files opened for analysis. And from that, you can probably guess why it has not been analyzed or modified so easily. This entire source code is protected by the ionCube protection system. The ionCube protection system is encoding PHP scripts. First it compiles them into bytecodes. The whole project started from earlier development that was intended to improve the performance of executing server-side PHP codes by first converting them to bytecodes for faster loading. Now, ionCube builds on this, and it encrypts this precompiled bytecode. And additionally, the compiled and protected codes are given a signature for the integrity checking. They can be given an expiration date, and what comes very handy for software developers. They can have restriction on IP addresses or server names or MAC addresses. When I was checking a collection of about 50 different exploit kits, I was surprised to see that only 9 of them used any kind of protection guarding the PHP code from analysis or reverse engineering. And of those 9, 6 was using ionCube. So this is probably this is evidently the most popular choice of cyber criminals when protecting their server-side components. Now, the ionCube protection gives you opportunity to obfuscate local variables, line numbers, and which is the most devastating for reverse engineering, obfuscate the function names. It also, as I said, can give you restriction on domain names and IP addresses. As a simple example, here is this sample code. After applying ionCube to that, you get this code, this source file. The first is a loader. It's a static loader. It's always the same for all protected files. The second part is the encrypted and signed almost original code. It is not impossible to decode ionCube. There are some tools available for that. One of them being ionCube decoder. The other is Descender. From the original code, they make something that looks like the original code, or resembles the original code. In very simple cases, it's equivalent to that. In more complicated cases, it doesn't even compile. When looking at the server code and applying one of the decoders, I ended up having code lines, this one or this one with the other, the compiler, not easy for analysis. And this was the reason why no one could get any useful results out of the leaked out source code, because they couldn't step over the problem of figuring out what are these things are in the source code. These are the obfuscated function names. When someone selects using during the ionCube encoding the obfuscate function names, it can provide a password to come along with that. In that case, the built-in PHP functions are replaced with obfuscating the blob or encrypted value of the original function, and this algorithm is perturbed with a provided password. So if you don't know the original password, you cannot possibly get back the function names that started the whole process. I made my tries about 5 to 50 times to try to guess the password that was used for obfuscating the function name, but it was unsuccessful. Evidently, these functions were protected more thoroughly than the server itself. Anyhow, there were some ways to go over that. For example, malware authors don't have time to write every code from scratch, so they are using cookbook examples that are available on the internet. So by looking at this code, it looks like some sort of generic SQL connection database loading the code. So guessing which function could be used in that context, it gave me a way to find out some of the functions in this code. In the other case, some of the constants used in the code or in the function parameters are revealing. For example, in this case, I see here which is some sort of a pass, and this is some sort of a date. And the only function that matches this parameter pattern is the setCookie. And in that case, I could figure out this one, which is a setCookie function, and this one, which should be at the time to set up a cookie time life for that. In other cases, when the code was already clear enough, I could base something on the functionality of the code. Like in this case, it is certainly some sort of array comparison. And this should be some upper boundary of the array. So this function was also solved. In other cases, like this one, it was writing out one of the statistic pages. And in this case, this writes out some size value and some operation on a file. And checking out the available user interface screenshots, it is obvious, if you can decode Russian, that after the size string should be the actual size of the function of the file. So this should be the file size function. This was the first part of the work. The second part, it would be pretty useless if we cannot use it understanding the operation of the server backend and find out how does it affect the malware distribution. So a typical Blackhole attack looks like it is originating for an incoming email or some drive-by exploitation. There we get an original starting link. The starting link is hosted on some hacked website. The number of these hacked websites can be from a couple of dozens to a couple of hundreds. These sites all point to 2 to 5 other hacked websites which contain a small script. A small script just does the redirection, and at that point we are hitting the server that is hosting the exploit kit. These are all usually hacked websites all over the web, and these are the happening that are going on the web server maintained by the malware author or distributor. So the typical attack in the email case starts with receiving emails like this. I should mention that in case of the Blackhole attacks, it was different from the the earlier observed fake AV or botnet distribution attacks, in a sense that the first stage email that didn't try to invoke lower level human instincts, meaning that the messages did not contain anything about nudity, porn, and sex. All these letters were coming from some sort of official organization like Internal Revenue Service, DHL, Better Business Bureau, and NASA online paying services. So these were all some official looking emails. And they pointed to locations. For example, in this particular attack, it was clear that the sites where the first stage redirections are hosted are all hacked WordPress installations, abusing one of the WordPress security vulnerabilities. And then after the redirection chain, we hit the server hosting the Blackhole exploit kit. The first encounter is what is referred in the code as the main file. This is the main file that gathers together the exploit tailored for the infectee computer. The link passes a query parameter. This parameter is the identifier of the distribution campaign. It is serving for the purpose that on the same server can be hosted several distribution campaigns, all distributing different malware and all distributing different type of exploit distribution. The main file generation scheme is very simple. When the user opens the email, clicks the link, and redirects to the exploit kit hosting page, in the request arrives its operating system version, its browser version, and based on the information, the TDS of the exploit kit, TDS functionality of the exploit kit can look up whether for this IP do we have a specific rule. If they have a specific rule, they check for this operating system, what are the exploits that are selected. Then for this browser, what are the exploits that are selected on the admin interface to be delivered. And based on these settings, a chain function call is generated, which is returned for the user. It looks like that if the exploit 1 is selected for the particular platform, then its code is inserted and calls the exploit 2. If it is not selected, then it is just a simple call to a simple empty function and calls to the next exploit function. And these are changed one after each other. And at the end, it calls the end redirect function. It should either redirect the browsing to an innocent page like one of the Google pages, or in rare cases it has a direct link to an executable malware, and the chain ends there. And on top of this is a JavaScript code. On top of it, there is an encryption added to this, and an additional code is appended to this in case JavaScript is disabled by the browser settings. There is an additional attack surface that will be introduced. So the main script looks like something like this. There is a huge blob of data, which is the encrypted main script. It can either be stored in a huge array or in some text areas of the HTML page. At the bottom, you see the end of the script, and this is the no script page, which is no script part, which is generally a reference to a Java archive. A Java archive which does nothing else but downloads an executable using one sort of Java vulnerability that is available, that is working on the target computer. The parameter that is passed to this Java archive is a replacement cipher of the URL that hosts the executable content. In this case, this is sumatranayuga.russia and refers to the download file component of the exploit kit. The download file component is responsible for serving the binary payload back to the user, and also by receiving this E value, which identifies which exploit triggered this download. It can keep track of the exploit, a success rate of the exploits being delivered to the particular computer. This F value identifies the particular file that is to be distributed. On the same server, several files can be hosted, and this identifies which will be returned to the user. This code in the middle, it just decrypts this data. It is split by the M values, and if you have good eyes, you can recognize that every second value is a half value. So this is a decimal representation of a string codes, ASCII codes, and every second contains only the half of the particular ASCII code. And this is what's decoded by this simple script. When it is decrypted, this is the main script that is responsible for distributing the attack on the user computer. The first is the redirect call, which is at the end of the call chain. It just directs to Google.de. The next part is a public library, public JavaScript library called plugin detect. It is its purpose is to identify the exact versions of plugins that are installed in the user computer. It can identify, for the purpose of the Blackhole kit, the Flash plugin version, PDF plugin version, and Java plugin versions. And this is the granularity of the TDS functionality of the exploit kit, depending on different values of the operating system and the installed browser version. The individual exploit function are turned on or off. So I will go through very briefly most of the exploit functions that are used. The first one is the very simple one. The first line is very interesting because it can show you that the SPL1 exploit function is not even present. It has never been present in version 1.2 of the exploit kit. It was left out in some earlier versions. It was actually containing some Java exploiting code. This code, the second exploit function, is a generally used downloader code. It was used in several VB script downloaders using the XMLHTTP object to download content to the host computer, and the ADODB stream to save it to a local file, and after that it executes it. In the SPL3 function, it downloads a PDF file which is exploiting, depending on the installed PDF version. These are the values coming from the plugin detect plugin. Depending on the values of that, it is exploiting, it downloads a PDF file which is exploiting either one of the classic PDF exploits like util printf or new media player or collab geticon, or the second one, which I took as an example. It's making use of a newer vulnerability, which I will see how we can get. The The main code is stored here also as some sort of decimal codes in one of the PDF fields. Actually, it is stored in many of the PDF fields. This part will be the most interesting for us. Obviously, everyone in the audience can recognize that this is a shell code, an unencrypted shell code. So, how we get to there? First, there is a JavaScript code that collects the author, subject, keywords, creator, and producer fields from the PDF. This is the author, and the others are missing here, just so that it would fit in one screen. After that, it decodes and executes it. After it is executed, we reach to the exploitation function, which builds the shellcode buffer. It gets it from the target, for the target title. As you could see, the title was holding this hex-encoded shellcode. The next vulnerability, which is not that commonly used, is the Windows Help and Support Center vulnerability. If a particular URL is specified in an iframe, you can overflow it to execute an arbitrary script, which is kind of an interesting concept, because normally when you are overflowing an argument, you could execute a binary code. But this time it is script, and this script is also the XMLHTTP plus ADODB downloader. The next exploit function is using one of the Flash vulnerabilities. Now, this is part of the main script. It has a couple of interface functions and the shellcode itself. And at first, it loads the field.svf file, which, if you decompile it, and you cannot see it really, it calls the external interface functions. External interface functions are used in the Flash scripting language to access the functions from the hosting HTML page. In this case, the get block size, get alloc count, the get field bytes, it just fills in the heap so that it will be appropriate for exploiting. After that, it calls the getCN function somewhere around here, and that getCN function loads the next stage of this attack, another Flash file. That Flash file will call and execute the get shellcode function, which is returning to the heap the shellcode and executing it. The shellcode itself is a very general shellcode. It's XOR encrypted once the encryption is removed. It has a download functionality, URL download to file, then executes it. And here is the final URL where it grabs the executable content from. And the Blackhole exploit kit makes use plenty of Java vulnerabilities and the Java files distributed on there. In fact, it is the most popular attack used by this exploit. In this case, there is an applet archive. This archive always gets the encrypted URL as a parameter, and it downloads the file from the URL. Either the strings are obfuscated in the Java code, or a sort of protection tool, the Zilix class master, is applied to the code, which obfuscate not only the variable names and the parameters and the constants, but also the code flow. The next one is the XML, the last one, I believe the last one is the XML core services vulnerability. This is a brand new one. The first sample we have observed in somewhere around March, most likely in targeted attacks. In May, we have seen the first public reference to this code on Chinese blogs. And in June, Microsoft advisory was published. Okay, I will find the right button, no problem. June 16th, the proof of concept code appeared in Metasploit, and then a week later it was added to Blackhole. Why was it added to Blackhole? I don't entirely understand, probably because some security blogger kept asking the author of Blackhole when will he add support for it. Because only like 1 or 2 attacks use this exploit. And if I was looking, when I was looking at the code, you can see that the normal Blackhole code is very dense in a sense that it doesn't contain any indentation. And you see, at this point, here is the added exploit function, completely different indentation and coding style. If I compare it to the original Chinese published exploit code, which was published back in May, I could see that the variable names, the constants, the coding, the indentation is exactly the same. So actually it was copy-pasted into Blackhole, I believe as a PR move, just to prove that, it contains this vulnerability. So anyhow, let's take a look at the exploit statistics. We are reaching the end of this presentation, and I would like you to go home with a message. The message is from the statistic page of the Blackhole exploit kit, there is a distribution by the breakdown by countries. You can see Hungary is around here. Not too much infections, but you should be worried about this 34%, which is the infectability rate of that particular country, which means how many targeted computers were successfully infected. If you compare this column, you will see that Hungary is the most infectable country for Blackhole. And it is not just this case. I have checked a couple of other available statistics. It's not always that Hungary was the first, but it was always in the first 4. So I would say that Hungary is in a pretty miserable state as far as protection against web-based threats is concerned. The other interesting part here is that the most successful attacks are always Java. And when I started analyzing the server code, I had a couple of original questions that I wanted to be answered at the end. The first one was, why Java? Why is this the most attacked vulnerability? And it's not just Blackhole statistics. If you compare any stats coming from Kaspersky or Microsoft, you can also see that the most attacked surface right now is Java. So I had a few misconceptions at the beginning. I thought that the malware, the exploit distribution logic is flawed, that it favors Java. It turned out to be not true. I thought that, as you could see, it's an event of chained functions, and Java is being served first. So if there is an error or unhandled condition in this chain, then the further exploit function don't get effect. So that could be a reason. But that's not true, because in our tests on Windows 8, where no plugins are available, this chain of functions goes right directly to the end redirect function. So runtime errors are handled properly. Then I thought that there is some restriction in the code that, no, not the code, the server logic, that in the case through one of the ways an exploit already handed the binary payload to the computer, the subsequent exploit will not deliver, and they will not get into the statistics. That was not the case either. So what I was left to do is to follow in this particular case the advice of the greatest detective ever, Sherlock Holmes, who said that if you eliminate the impossible, then whatever remains, however improbable it is, will be the truth. So I eliminated all these impossible things, and I ended up with a conclusion, however improbable is, that the Hungarian computers are not patched for Java vulnerabilities. And I know it sounds incredible for you, but that is the truth. And it's not entirely the user's fault, because they are not really helped by the application developers. So this is just very quickly a recent example of an Apple OS X Java update. So it says that there is this update for Java. So when I look at it, shall I hurry installing this update? I can see in text it says something like it's addressing a performance issue. Should I be worried? Anyway, there is this link about some security content of this update. So just to be sure, I checked the security content. It lists two very unremarkable CV IDs which are not remotely exploitable. So I should say I'm safe here. But just to be sure, there is a Java update version, so I should check the Oracle website. And when I check the Oracle website, here I see a completely different CV number that is fixed with that Java update. And now that CV number, it already rings a bell, because that is fixing a publicly exploited vulnerability that has been observed in the wild. Not only that, but it is multi-platform. It can work not only on Windows, but on OS X and Safari. And not only that, but it has already been added to the Metasploit framework. So not mentioning it in an Apple advisory, I would say it's downplaying the importance of Java. So the greatest problem is that users are not aware of Java being a source for a threat or a vector for attacks. So my piece of advice is be prepared, because you are likely to get target of an attack. And you have to install all the latest updates, even if it is Java, even there. And at the end, don't be stupid, because when all the attempts fail, you will end up in a dialog box asking you, do you want to download and execute this program? Don't do that. Don't do that. As I expected, I don't have time for questions, so thank you very much for your attention. You can find me in email. Thanks.